Well, hello grade 9s. I promised you a video today that would explain how you answer the questions on the test. So I'm going to explain it, and I'm just going to please ask that if you don't understand how to do some of these questions, please watch the video first. Fast forward to, I'm going to take the questions in order, fast forward to where you need to be to get your answer, and I will take it from there. Okay, so let's do the multiple choice first. So it's going to take a little while to go through this whole thing, so I'll explain all the steps when we get there. All right, one at a time. The moon orbits 6 times in so many days. The period of revolution would be 27. Okay, it'd be 163.8 divided by 6. All right, now this question about phase, like which things have the same phase. Phase is when these particles, by the way, okay, let's say your particle F. Particle F moves up and down, okay? So what it does is right now it's on the way down because this crest passed underneath it, and so it's on the way down right now. Okay, and it's going to move down to the bottom of this trough over here as the trough moves over, so it's going to go down like that. And then it's going to go back up, right? Wow, this is not a great way to do it maybe, but anyway, it's hard for me to animate something. It's going to go up and down with the wave, right? Right now it's on the way down because a crest, this crest right here, just passed point F. So it's on the way down because this trough is about to come underneath it. And when that trough comes underneath it, it's going to move to the bottom of the trough. Okay, so what in phase means is that the particles are doing the same thing at the same time. Now, if particles are in phase, it means they have to be on the same part of the wave. So here, for example, we can see that particle A and particle E would be in phase because they're on exactly the same part of the wave. Okay. However, waves that are half a wavelength apart, okay, instead of a full wavelength apart, are out of phase. So this is going to seem kind of weird to you, but look at particle X and particle Y. See, one is behind a crest and the other one's in front of a crest. So they're going to be out of phase. Particle Y is on the way up right now as this crest is about to move past it. But particle X is on the way down right now as a trough is about to move past it. So the answer is X and Y. Okay? I guess I'll highlight it in yellow. How many wavelengths are there between A and H? Well, if you look at A, okay, if you look at A and you look at H, it's one wavelength from here to, from A, okay, pardon me, let's go back to black. From A to E is one wavelength, and then H is another half of a wavelength further. So this distance would be one wavelength plus a half. So the answer is C, 1.5 wavelengths. Okay. What direction is particle E moving at this moment? Well, what's about to come to particle E? Remember these waves are moving, I'm going to switch back to this. Remember these waves are moving this way, right? So it's on the way down. Okay. You might be thinking it's on the way up, but the particles only move up and down. Right now, a trough is about to move underneath it. So the answer could only be either up or down, and in this case, it's definitely, I'm having a hard time with these pens, it's definitely down, okay? All right, now moving on. A periodic wave makes crests, so the frequency is 2 Hertz and the speed is 5 meters per second. Then basically what is the wavelength? Well, it's going to be speed divided by frequency. So let me write down the step for you. It's going to be wavelength equals speed divided by frequency. 5 divided by 2 is 2.5, okay, meters. What's the frequency of a wave that have a speed of 0.4 and a wavelength of 0.2? So here you're going to use the same equation, but you're going to go F equals V over lambda, okay? So that's equal to 0.4 divided by 0.02, and that is 20 Hertz. And so there's your answer there. I might as well just use this. Okay, a pendulum has 40 vibrations in 2 seconds. So its period would be 20 divided by 40, 20 seconds per 40 cycles, right? That's 0.5 seconds, okay? It's not 0.5 hertz. The period is 0.5 seconds, right? A period of this, okay, so how do you find period when you're given, or frequency when you're given period? Frequency equals 1 over t. In the previous question, we used t equals time over cycles. Okay, so 1 over t, that's 0.005, whoops, 0.005, take the reciprocal, and you get 200. So the answer is 200 hertz. Okay, so that takes care of that one. The speed of sound in air is 345. What's the temperature? So we're going to use this equation. 345.6 equals 332 plus 0.59 T. Okay, we're going to solve it for temperature. So 340.6 minus 332, just use BEDMAS, right? And then divided by 0.59, and you get 23.05. So the closest answer would be 23. Okay. Bats have a certain frequency, and what is the wavelength? So again, lambda equals V over F. So just go 350 divided by 5.5 exponent 4 is 0.006. So that's 0.006 meters. That's 6 millimeters. Okay, so you have to convert it to millimeters. That picture is diffraction. Okay, so which overtone is this? So the first harmonic would be one of these like things. The second harmonic would have 2, third harmonic 3, and fourth harmonic would have 4. So this is the fourth harmonic. So this is the fourth harmonic. But remember that the first harmonic is called the tone, and the second harmonic is the first overtone. So this is the third overtone. Okay, so it is that one. Okay, if the rope is 50 centimeters long, what's the wavelength of the waves? Well, there are 4 antinodes. Each one is half of a wave. So there's 2 full wavelengths. So this is 2 wavelengths across here. So the rope is 50 centimeters long, so we're going to go 2 wavelengths equals 50 centimeters. So therefore the wavelength would be 25 centimeters long. So the answer is 8. Okay, a standing wave with sound waves of wavelength 60 centimeters forms in an open-ended air column. How long is the second resonant length? Well, in an open-ended air column, the second resonant length happens when the length is 2 over 2 wavelengths. Okay, so if the wavelength is 60, okay, then 2 over 2 times 60 is just 60 centimeters. Okay, so the second resonant length would just be 60. That's it. Okay, examine this diagram. Which harmonic is this? Well, the first harmonic doesn't have these antinodes in the middle. Okay, it just has these 2 ends. So this is second, that's the third harmonic of this tube, right? There's 3 antinodes there, so it's the third harmonic. Which does not transmit sound? The vacuum of space does not transmit sound. Anything that's made of matter does transmit sound. Loudness corresponds to which physical quantity? The answer would be amplitude. Some students will write decibel. That's how you measure it, but it's the amplitude of the wave is the physical characteristic of the wave. Okay, it's not the unit, right? It's like me saying height. What does height correspond to? You wouldn't say meters. You would say it corresponds to how tall you are, right? You wouldn't just say the unit meters. Okay, so anyway, that's why it's amplitude. Okay, so a closed-ended air column is this third resonant mode. How many wavelengths will fit across the column? So in the third resonant mode for a closed column, the first one is 1/4, the second one is 3/4, and the third one is 5 quarters of a wavelength. Well, 5/4 is equal to 1.25 wavelengths. So the answer is D. Okay, a tuning fork vibrates at 440 hertz. Second tuning fork produces beats with the first one at 7 hertz. Okay. When an elastic is tied around the first fork, the new beat frequency is pardon me, I'm going to turn off my sound on my phone. The new beat frequency is 3 hertz. What is the frequency of the second fork? All right, so the way beat frequency works is this. We know one fork is 440 hertz. Now, if the beats are 7 hertz, that means the second fork has to be one of two numbers. It could either be 447 or it could be 433. Okay, so it has to be one of these. So we know the answer is either A or B. Now, how did I get these two numbers? Well, the difference between this and these guys has to be 7. Okay, so beat frequency is the difference between the two frequencies. Now, what happens is you tie a an elastic band, okay, around this guy. That's going to lower its frequency. So it's going to go from 440 to some lower number. Okay. In fact, we know what the number is. It's going to go 4 hertz lower. Okay. And now it's going to be a beat frequency of only 3 hertz. So because the elastic band lowers this one and it gets closer to the second tuning fork, now the beat frequency, okay, now the beats are 3 hertz, then it has to have been the lower number. Okay, so the lower number is the correct answer, 433. And that way, when we tie an elastic band around the 440 and it reduces its frequency, it gets closer to the other tuning fork, so it has to be this one. Okay. All right. A note on a keyboard has a frequency of 200 hertz. How many octaves higher if it's 800 hertz? Well, 1 octave, you double the frequency, so it goes from 2 to 400. If you double it again from 400 to 800, that's 2 octaves. Okay, so we started at 200. The first octave would be 400, and the second one we would double 400 again, so that would be 800 hertz. So this is 2 octaves higher to go from 200 to 800. Okay, so you go like this. If you're trying to understand this question, 200 to 400 would be 1 octave. But then 400 to 800, you double it again. This is 2 octaves. And then 800 to 1600, that would be 3 octaves, right? And so on. Okay, and that's how it works. All right, a plane is making a maneuver at Mach 2.17. What is the speed in kilometers per hour if it's 0 degrees Celsius? All right, it's Mach 2.17. So some of you are asking me about this question, Sasha, okay? And the Mach number goes like this. 2.17, what it means is that the speed of the object is 2.17 times the speed of sound. That's what the Mach number means. Okay, it's how many times the speed of sound it is. So it's 0 degrees Celsius, so it's 2.17 times 332. But we have to convert that to kilometers per hour. So first, I'll just go 2.17 times 332, and I get 2.17 times, I got the number wrong, times 332 is 720.44. But that's in meters per second. I need to convert that by multiplying by 3.6, okay, to kilometers per hour, and I get 2593.6 kilometers per hour. Well, that corresponds to that number right there. Okay, the decibel level of a sound that is 4 powers of 10 more than 30 decibels. Well, every 10 times more is 10 more decibels. So I'm going to have to add 40 decibels to that. So from 30 plus 40 is 70 decibels. Okay, if you have a loudness of 70 decibels, what's the intensity of the sound? Well, you start at 10 to the minus 12, and then you're going to have to add 7 to negative 12. So it's 10 to the minus 12, right? Plus 7, okay? Because it's 70 decibels. That's where the 7 comes from. Okay, so negative 12 plus 7 is how much? That's negative 5. So the answer is D, 10 to the negative 5. A sound wave has an intensity of 10 to the power of 2 watts per square meter. So that is 14 powers of 10 higher than, see, so if it's 10 to the negative 12, I would have to add 14 to make it 10 to the positive 2. Okay, so then times this number times 10, and I get 140 decibels. All right, moving on. The part of the ear that contains thousands of tiny hairs is definitely the basilar membrane, okay? Or the cochlea. The basilar membrane is in the cochlea, okay? So, but the cochlea is not an option, so we're going to use basilar membrane. This part of the ear would rupture at 150 decibels. That's the eardrum that would rupture. This structure channels sound from the air towards the eardrum. That's called the auditory canal. Okay, that's structure number 2 in that picture. What is structure number 9 in this picture? Those are the semicircular canals. What structure is responsible for equalizing pressure? That is structure number 12, the eustachian tube, right there. Okay. What's the function of number 6? Number 6 is a bone. So what it does is it carries sound from the tympanic membrane into the cochlea. That just carries the vibration, right? That's what those 3 bones do. Okay. They also amplify the sound. Okay, so it's kind of like an amplification system. What is the function of number 11? Number 11 is the auditory nerve. So what it does is it carries nerve impulses to the brain. What is structure number 3? Structure number 3 is the outer ear there, that's the pinna. Okay. Which of the following frequencies are the most consonant? They would have to occur in the simplest of ratios. So the one that reduces to the simplest is actually this one that reduces to 1 to 2. These ones, that's not reducible. This one reduces to something complicated. This one reduces to 10 to 11, which is still complicated. So 1 to 2 is the simplest, and that's it. Okay. Biff is playing a note of 200 hertz. Bob is playing 197 hertz. So the beat frequency would be the difference between the 2 numbers. It cannot be a negative number. Okay. So what's the difference between 200 and 197? 3. So it has to be D only. What is the loudness of a sound you can hear for a note of 100 hertz? Okay, for that, you have to look on the formula sheet. Okay, so look. I go to 100 hertz, right? And then I go up to the bottom of this blob, okay? And that corresponds to 40 decibels. So a sound at 100 hertz would have to be 40 decibels at least for me to hear it, okay? So let me go back to the test. So the answer is 40. There you go. All right. Okay, so that takes care of the multiple choice. I think I will stop this video here and then I'll do a separate one for the written question.